Sample problem 3.15 kind of builds off of sample problem 3.14. We're still talking about that same equation. So before I even read the problem, I'm just going to go ahead really quickly and write up our balanced equation that we had from that previous one. It was 2 copper sulfides plus 3 oxygens yields 2 copper oxides plus 2 sulfur dioxides. All right, and so it says, during the process of roasting copper 1 sulfide, how many grams of sulfur dioxide form when 10 moles of copper 1 sulfide react? So again, this is going to be a conversion type problem. Notice they're giving me the moles of copper 1 sulfide, and they're asking the question about sulfur dioxide. So I know that my balanced equation, right, is going to be my conversion factor, because by looking at my balanced equation, for every 2 moles of copper sulfide, I can form 2 moles of sulfur dioxide. So let's start to write this down. I've got 10 moles of copper sulfide, and I'm interested in sulfur dioxide. So from my balanced equation, for every 2 moles of copper sulfide, I can form 2 moles of sulfur dioxide. Right, I got that directly from looking at those stoichiometric coefficients from the balanced equation. So that means, right, so moles cancels moles. That means, and 2 cancels 2, because that's equal to 1, that I'm going to have 10 moles of sulfur dioxide. And the question is asking for how many grams. So what conversion factor do we have that relates moles to grams? And if you'll remember, it's the molar mass, right, from the periodic table. That tells us the grams per moles of something. So I have 1 sulfur. So if I look on the periodic table, it's number 16. Molar mass is 32.065 plus 2 times the molar mass of oxygen, which is 16, equals. And so from the molar mass, from the periodic table, for every 1 mole of sulfur dioxide, there's 64.065 grams of sulfur dioxide. So moles divided by moles equals 1. They cancel. What's that going to equal? 640.65 grams of sulfur dioxide.